Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So we've got to first of all work out how many parts there are altogether. So we're told that the ratio of red, yellow and green is 3 to 2 to 4. So to work out how many parts there are altogether, we do 3 plus 2 plus 4, which is 9 parts. So there's 9 equal piles of sweets. Okay, but to work out what one part or one pile of sweets is worth, we're going to get the 99 sweets and divide it by the amount of piles, and that's going to be 11. So one part is worth 11 sweets. We're asked to find out how many yellow sweets, and yellow is the middle one, so it's going to be the 2. So yellow has 2 piles of 11 sweets. 2 times 11 is going to be 22, so it's going to be 22 sweets. First of all, we're going to work out what angle BCA is. And the way of working this out is it's going to be the same as what BAC is, because the angles in an isosceles, the bottom 2 angles in an isosceles, when it's pointed up, are equal. So this is also going to be 15x. Make sure you state the reason. So it's an isosceles triangle. Okay, so if this is also 15x, we know that angles BAC plus ACB plus ABC, so basically all 3 of the angles in the triangle, are going to add up to 180. So 15x plus 15x plus 30x is going to equal 180, because it's angles in a triangle. Get my lines in, my tram lines in. 15x plus 15x plus 30x, well 15 plus 15 is 30, 30 plus 30 is 60, so it's going to be 60x equals 180. Then we're going to divide both sides by 60, and we have x equals 3. So the answer will be 3. So we're asked to reflect this shape along the line y equals x, and y equals x is a diagonal line where all the x values are equal to the y values. So at the bottom here we've got x is 10 and y is 10, so that coordinate would be 10, 10. And then obviously this coordinate 4, 4, etc. So we need to reflect it across this line. And so if I pick a point, I'm going to pick the top one. We can see it goes 4 diagonals to hit that line. So 1, 2, 3, 4, so it will go another 4 diagonals. So that will be one of the coordinates there. And I'm going to do the same with the bottom one. So 1, 2, 3, 4, 5, 6 diagonals. 1, 2, 3, 4, 5, 6 diagonals. So it will be there. And then finally, I'm going to do this slightly harder one. So we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Kind of goes over the other one, ends up here. So if we join these up, and we need to label it B. We're going to start off by writing the numbers that the dots are at. So we've got minus 12 and we've got minus 5, and x is anywhere between those. Now it's obviously going to be greater than minus 12 and it's going to be less than minus 5, but it can equal minus 12, and the reason for that is it's a filled in dot, but it can't equal minus 5 because that is a hollow dot. The median is the middle number when the numbers are in order. Now it's quite difficult to do with a table, so we used a formula, and that formula is to find the position of the median. We do how many numbers there are, which I'll call n, we add 1 to it, and then we divide that by 2. And that shows us where the median is. It doesn't tell us what the median is, it shows us where it is. Now, we need to figure out where these numbers are in this list. So the first number is a 2, and there is 1 of those. The next number is a 3, and there's 3 of those. So 1, 2, 3. The next number is a 4, and there's 4 of those. So 1, 2, 3, 4. The next number is a 5, and there's 8 of those. So 1, 2, 3, 4, 5, 6, 7, 8. And the next number is a 6, and there's 13 of those. Now, I'm not going to do all of them, okay, because we're not going to be working out the median by writing out all the numbers, but I do want to show you where these numbers are coming from. So what we do is we do a running total. So I'm going to do a running total. The running total is just adding up the frequencies as we go. So the first one is just 1. Then we're going to add the 3 in the next row, so that's 4. Add the 4 in the next row, 8. Add the 8 in the next row, 16. Add the 13 in the next row, and that would be 29. Now, we use the running total because the running total shows us where the last number is in that group. Okay, so this shows us that the first number is the last number that is a 2, which is true, we can see it here. This 4 shows us that the fourth number is the last number that's a 3, so let's check that. 1, 2, 3, 4, it works. This 8 shows us the 8th number is the last number that's a 4, let's check that. So 4, 5, 6, 7, 8. This 16 shows us the 16th number is the last number that's a 5. So 9, 10, 11, 12, 13, 14, 15, 16. And this 29 here shows us that the 29th number is just the last number, but it's the last number that's a 6th. Okay, so let's work out how many numbers there are. And we do that by adding up the frequency. So we're just going to add up all of the frequency together, and we find out that there's 29 numbers altogether. So 1 plus 3 plus 4 plus 8 plus 13. So using our formula, which is 29 plus 1 divided by 2. 29 plus 1 is 30, divided by 2 is 15. So we're looking for the 15th number. So looking down our running total list, well, the last number that's a 4 is the 8th number, so we haven't got to the 15th number yet. And the last number that's a 5 is the 16th number. So if the last number that's a 5 is the 16th number, then surely the 15th must also be a 5. And so our median is 5. So in this question, we basically need to add the 2 3/4 and the 2 2/5. So we're going to do 2 3/4 plus 2 2/5. Now, if I just rewrite this, 2 3/4 can be written as 2 plus 3/4 plus 2 plus 2 1/5, or 2/5. So we can add the 2 2's together to make 4, and then all we need to do is add the 3/4 and the 2/5. So when you add two numbers with different denominators, what we need to do is get the common denominators. And we do that by just quickly writing out the 4 and the 5 times table and seeing what the first number in both their times tables is. 16, 20, and 5, 10, 15, 20. So that's 20. So we need to get the bottoms of the fractions to 20. Now for 3/4, to get the bottom to equal 20, we need to times the 4 by 5. And whatever you do to the bottom, you've got to do to the top, so times that by 5 as well, which will be 15. And for 2/5, we'll get that bottom to 20, so we times that by 4. And so we've got times the top by 4 as well, to make it 8. So it's going to be 15 over 20 plus 8 over 20. So we need to add the numerators. So it would be 15 plus 8, which is going to be 23 over 20. Now that is a top-heavy fraction, so we can rewrite that as 1 3/20. And we can add the 4 and the 1 together to make 5 and 3/20. So the answer is 5 and 3/20. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now this might surprise some people because they will probably think it's a ratio of 4 to 1. But we can show here that it's a ratio of 3 to 1. We're going to start by looking at the numerator and the denominator separately. So looking at the numerator first, we've got 9 to the power 16 times 9 to the power 46. Now when you have two powers of the same base, so they're both 9, base 9, but base is the big number, then what you can do is you can add the indices. So we're going to do 16 plus 46, which is 62. So it's 9 to the power of 62. And looking at the denominator, well, you've got a power inside and outside the bracket. Whenever you have that, you can just multiply them. So it'd be 9 to the power of 40. Now, whenever you've got a division between two powers of the same base, which we have here, it's 9 to the power of 62 divided by 9 to the power of 40. We just take away the indices. So it'd be 62, take away 40, which will be 9 to the power of 22. So our answer is 9 to the power of 22. So to answer this question, we've got to first of all work out what transformation it's going to be. And it hasn't changed size, it has changed its way up, and it's obviously going to have been rotated. There's going to be a rotation. And for a rotation, we need to know the angle which it's rotated and where the center of rotation is. Well, it's obviously gone 90 degrees, it's gone a quarter turn, so it's 90 degrees, and it's gone that way, and so that's the same way as a clock goes, so that's a clockwise. And we need to find the center of rotation, so we need to find out where the center of the rotation is. So the way of doing that is just trace out the shape you've got. So trace out A. And it's going to look something like this. And trace it out. Just connect those bottom bits a little bit better. And trace it out. And what you've got to do is you've got to find out where on this page you put your pencil when you rotate it. And so you're just going to rotate it with putting your pencil somewhere. So you want to end up with it looking like this on the tracing paper, and you just with a bit of trial and error you'll realize that you can put your pencil here. So your pencil will go at 2, 2 to get from A to B. So our center of rotation is going to be 2, 2. So with each of these pools, try and imagine it being filled. So pool A, first of all, we've got water coming into it, and it's actually going to go quite quickly initially, and then it will hit a point at the end where actually it will go really quite slowly because it's a wider pool. So we would imagine that the graph for pool A would actually go quite quickly at the start, and then at the end it would go much slower. And that doesn't really describe the graph. The red graph doesn't really describe that at all. So for pool B, we start off actually quite quickly because it's quite thin, and then we have a wider bit here, so it will go slower here, and then we go quickly again. So we need a graph that starts off quite quickly, then goes slowly, and then goes quickly. And the steeper the graph on our depth time graph, the faster it's filling up. And that red line doesn't really describe that either. Pool C, however, we can see it goes slowly at the start, and then because it's thin it will go quicker, so nice quickly, and then it will go slowly again. Well, that is a perfect description of the graph that we're given. So the graph we're given is definitely going to be for pool C. To work out the area of a rectangle, we just multiply the width and the length. Here they are mixed numbers, so all we do is the width times the length. Now when you multiply with fractions, always make them top heavy first, or improper, and to do that you times the big number by the bottom and add it to the top. So we're going to do 1 times 2 and add it to the top, so 3 over 2. Same with this one, 1 times the 3 at the bottom, added to the top. 1 times 3 is 3, add to the top is 5. Now we've got to get the numerator, we don't need to get the numerator the same, we're multiplying. All we do now, really easily, is just multiply the tops and multiply the bottoms. So we've got to convert 15 over 6 into a mixed number because it asks for a mixed number. So 15, how many 6's go into 15? Well, we're first of all going to have 2 whole ones, and how many left over? There are going to be 3 left over. Now 3 over 6 is the same as 1/2 because we can divide top and bottom by 3. So our answer is 2.5. To answer this question, we need to know what an equation, expression, formula and identity is. So the formula is basically an equation but for real world things. So area equals pi r squared. It's where the letters actually mean something. Expression is just algebra without the equal sign. So 5x plus 3 would be an expression. An equation has an equals and it can be solved, so you can find out what x is or find out what a is. And an identity is true for all values of that letter. So an example would be x times x equals x squared. That's an identity because that's true for all values of x. So looking here on the right hand side, we've got 3x plus 2x. But if we imagine x is 10, so 3x would be 30 plus 2x would be 20, 30 plus 20, well that will equal 5x, 5 times 10. And actually this is true for all values of x. And the reason it's true for all values of x is we know that 3x plus 2x, this right hand side here, equals 5x. They're the same thing. Now normally with an identity, it's shown with 3 lines. Now in the exam, this type of question, it won't be shown with 3 lines because that kind of gives it away that it's an identity. But this question is definitely an identity. And you can't solve it because it's true for all values of x. So yes, x could be 10, x could be 1,000,000, x could be 1/3, x could be anything. So here we're asked to find how many bread rolls we can make. We've got 89 kilograms and it takes 0.08 kilograms to make a bread roll. Something we can do is convert these into grams, or we can just keep it at kilograms, but I've got a neat little trick. And the trick is, if you've got a decimal when you're dividing, as long as you do the same thing left and right, you can multiply them by 10 or 100. In this case, we're going to multiply both by 100. Because it will make the division a lot easier, because it will make this right hand side, instead of 0.08, it will just make it 8. The reason we can do that is 89 divided by is the same as 89 over 0.08. And as a fraction we can just times top and bottom by 100. So it would be this over 8. So now we can do the bus stop method. So 8 on the outside. And in fact I might use a straighter line here. There we are. And we've got 8,900 on the inside. So 8 into 8 go 1, 8 into 9 go 1, remainder 1, 8 into 10 go 2, remainder 2, and 8 into 20 go 2, remainder 4, and 8 into 40 go 5. Now, it says how many bread rolls can we make? Now, we can make 1,122.5. Well, half doesn't really count, so we're just going to say 1,122 whole bread rolls. Yes, we've got half a bread roll left over, but we are asked how many whole bread rolls can we make? I'm just going to write the question out so we've got a little bit bigger writing to play with here. And it doesn't actually matter which method you expand these brackets with. I'm going to use Smiles and Rainbows. So we multiply the 8 by the 10x, which will make 80x, and multiply the 8 by the 4, which will make 32. Now here we've got a minus 5 on the outside, so we do minus 5 times 8x, which is minus 40x, and minus 5 times minus 4, which is actually plus 20. And a lot of students will write take away 20 there, but that is a minus 5 on the outside of the brackets there. So it's minus 5 times the minus 4 there will give you a plus 20. Then 80x take away 40x, which will give us 40x. And 32 plus 20, which would be 52. So our answer would be 40x plus 52. So this question is asking us really to divide the 5 3/4 by 1 3/4. So we're going to do 5 3/4 divided by 1 3/4, because we're finding out how many of each of these towels, which is 1 3/4 meter, can be made when the total amount of cotton is 5 3/4. So first thing we're going to do is convert them to mixed numbers, to top-heavy or improper fractions, because at the moment they're mixed numbers and we can't divide or times if they're mixed. So we times the 5 by the 4 and add it to the top, which will be 20, and then add it to the top 23, and then do the same. 1 times 4 is 4, plus it to the top is 7 over 4. Now a little trick here is KFC. We keep the first fraction, we flip the second fraction, and we change the divide sign to a times sign. So we're going to keep this first fraction as it is, change that divide to a times, and flip the second fraction. Okay, whenever we multiply, we just multiply the tops, so 23 times 4, which is 92, and we times the bottoms, which will be 28. And now we need to convert this back into a mixed number. So first of all, actually we can simplify this, because we can divide top and bottom by 4, so that would be 23 over 7, and then make this a mixed number. So 7's into 23 go 3 whole ones, and then obviously 2 remainders, so it's 2 over 7. Now it asks us for the amount of towels that she can sew patterns into. Now the issue here is that she will do 3 whole towels, but then have some left over, but she doesn't have enough to create a 4th towel, so it's just going to be 3 as an answer. We're going to start by focusing on the A and B, which is 8 and 16, so in the middle is going to be 8 and 16. The next thing we're going to focus on is the fact that A is all the multiples of 4. Now 8 and 16 have both already been taken because they're in the middle. So the remaining multiples of 4 are the 4 there and the 12 there. So the next ones I'm going to focus on is the A or B. So A or B is in A, in B, or in the middle. So if we cross out the ones we've already used, so we've already used the 8 and 16 and the 4 and the 12, that leaves the 1 and the 9. I'm going to cross that out of our other list. And there's only 2 left in our everything list at the top. We've got the 3 and we've got the 11. So on the outside we have 3 and we have 11. So to answer this question, you need to just know the answer off by heart. There is a diagram that can help us actually get there. And if we just draw a right angle triangle and put the lengths as 1, not right angle here, we can use Pythagoras, a squared plus b squared equals c squared, to work out the fact that this is going to be root 2. Because it's an isosceles triangle, this angle here is going to be 45 degrees, and same with the bottom right one, but we're not interested in that. When we label it with our marked angle here, we've got the adjacent is here and the hypotenuse is here. Now we know from trigonometry that cos x equals a over h. The angle is going to be cos 45, and a is going to be 1, and h is going to be root 2. Now, this is a bit of a strange one with 1 over root 2, because we need to actually be able to rationalise the denominator. And basically what that means, if you haven't done surds yet, or you aren't doing surds, is you times Tom 1 by root 2. And so we end up with root 2 over 2. So if you ever see 1 over root 2 is absolutely fine as an answer, but if you ever see the answer as root 2 over 2, the two are actually exactly the same. So writing 1 over root 2 is fine, or writing root 2 over 2 is also correct. So we're going to first of all realise that this is a right angle triangle and we've got two lengths and an angle involved, therefore it's going to be trigonometry. So we're going to just label the sides first. The one opposite the right angle is the hypotenuse, opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now the adjacent doesn't have a number or a letter next to it, so it's not interesting, so get rid of that. Next we're going to do our trigonometry triangles. And so we've got SO, Ka, Toa. And we are just crossed out the adjacent, so we don't need this one and we don't need this one. And we're going to end up with SO, which is short for sine the angle equals opposite over hypotenuse. The angle is marked as x, so sine x equals root 3 over 2. You need to know from memory that sine 60 is root 3 over 2. And notice here that the x therefore is going to equal 60. So when we're doing column vectors and adding and subtracting them, we just literally add and subtract the top and bottom numbers. So a plus b minus c will be, just looking at the top, 9 plus 18 minus 9, 9 plus 18 minus 9, which will equal 18. And the bottom will be 9 plus minus 18, so really minus 18, and minus 9, and so that will be minus 18. So our column vector will become 18 minus 18. What I'm going to start off by doing is rearranging this equation so that it kind of matches this one. So I'm just going to write it down. And we want the n to be minus 2. So what I'm going to do is I'm just going to put my rearranging lines in. And we're just going to add 10 to both sides. Now, we've already got this line drawn for us on this graph. And so all we need to do is draw this line. So we've got y equals 10x squared plus 8x minus 2 drawn for us. We just need to draw this line, which is y equals 10, and see where they cross over to find the solutions. So y equals 10 will be all the way up at the top. Let's just make sure I get it nice. There we are. I need to move that up a little bit. There we are. And let's read off the values that that gives us. So it comes down here, and it comes down here. So the values it comes down to are minus 1.6 and 0.8. And those are our solutions. So the thing we know about triangles is their angles add up to 180. So what we can do is we can say w squared plus 84 plus w plus 3w equals 180. And let's just put that together. So it's w squared plus 4w plus 84 equals 180. Now, with quadratics, whenever we're looking to solve, we want to have it equal to 0. So what we're going to do is we're going to take away the 180 from both sides, so it equals 0. So we've got the w squared plus the 4w, but we want to take away the 180 from it, which will give us minus 96 equals 0. So with quadratics, when we're trying to solve them, we need to put them into brackets. And to do that, we need two numbers that add together to make the 4 here and multiply together to make the 96 here. So just going through different numbers for 96, and you can try different ones. The first letter in the bracket will be w, first thing in the bracket would be w. And I think it's going to be, well, it's going to be a positive and a negative to get that negative there. 96 is 12 and 8, so it would have to be, let's have a think. It'd have to be a positive 12 and a negative 8 to add together to make a positive 4. And 12 times minus 8 is minus 96. That works. And to solve, we look at the left-hand side first and get that equal to 0. So w plus 12 equals 0, and then solve it. So get our lines in. Take away 12 both sides. W equals minus 12. And we get the left-hand or the right-hand side. Get that equal to 0. W minus 8 equals 0. Lines in. Add 8 both sides. W equals 8. Now we've got two answers here, but it says value of w. Well, we can't have a negative angle. So we know we're looking for w to be positive. So the answer must be 8. So I'm just going to write this out again, just so we've got a bit more space. Okay, the way we solve this is very similar to solving an equation with equal signs, but this time we're going to do two tramlines because there's 3 sides of this inequality, and we need to get x on its own. So looking at the fact that we've got 3x plus or 3x minus 5, we're going to deal with that minus 5 first. So we're going to add 5 to all 3 sides. So add 5 here. So we'll just leave 3x in the middle and add 5 to the right hand side. Now we need to get rid of that 3, so we're going to divide by 3, and again we need to do it all 3 sides. So divide by 3 and divide by 3. So we've got x is greater than or equal to 7, and then we've got 10 is greater than x on the right hand side. So this question will probably need a Venn diagram just to make it a bit easier. So I'm going to draw a Venn diagram. You don't need to. If you can work out how to do this question without, you can do. But I think this is a really tricky question to do without a Venn diagram. So it says that they picked 2 activities. It was either painting, which I'll put as a P, and sport, which I'll put as an S. So let's start filling in the information it gives us. So 11 picked painting and sport, so that will go in the middle because that is painting and sport, and 11 didn't pick painting or sport, so they can sit on the outside. Now here's the problem. It says twice as many people picked sport than painting as one of their activities. So it's saying that the total number in let's just show it. The total number in the sport circle is twice as big as the total number in the painting circle. Now, what we can do is we can say, okay, so if the painting we label as x, then the sport will be 2x. But if you look, we've already got a number already in the sport, that 11 there. So in algebra, this will be 2x take away the 11 that we already know about. And the painting is the same. We know the whole thing is x. So what we're going to do is we're just going to take away the bit we know there, which is the 11, and it will be x minus 11. Now we know that there are 66 students in total, so what we can do now is add up all of the parts of the Venn diagram and get it equal to 66. So x minus 11 plus 11 plus 2x minus 11 plus 11, and all of that will equal 66. This is going to be some solving, so we're just going to put our lines in. Now here we've got x plus 2x, which is 3x, and if I put my tool right, there we are. And we've got minus 11 plus 11, minus 11 plus 11. Well, those just cancel out, so we're left with just the 3x equals, and then 66. We're going to divide that 3 both sides. So we've got x equals 22. So if we go back to our Venn diagram now, we can fill in the blanks. So instead of x minus 11 there, we've got 22 take away 11, which is just 11. Instead of 2x minus 11 there, we've got 22 times 2, which is 44, take away 11, which will be 33. So it says, find the amount that picked sport and not painting, which is this 33 here. So I'm going to write this equation again just a little bit bigger so we can work with it. And one of the rules with equations is you want to get rid of brackets and fractions first. So we've got a big fraction here, and basically a fraction just means divide. So we're doing the 82 and we're dividing it by 3x plus 5. Notice I've put a bracket around it, because what we're going to do is we're going to do the opposite of divide by that bracket. We're going to times both sides by 3x plus 5 to get rid of that fraction. Now on the left hand side that just gets rid of the fraction, so we're just left with 82. On the right hand side, well, we're doing the 2 times the 3x plus 5. Following my rules to get rid of all the brackets first. So 2 times 3x is 6x, 2 times 5 is 10. And you can use any method you want. Some of you might use this method where we've got the 2 here, 3x plus the 5, and then we times them, so it's 6x plus 10. That's how we can do it. Any method you like. And then we're going to take away the 10 both sides because we want x on its own. And so we've got 72 equals 6x. And then we're going to divide both sides by 6. And so we've got 12 equals x, or x equals 12. So to do a cumulative frequency graph, we've got to first of all add a cumulative frequency column to our table. And cumulative frequency is just a running total. So we always start off with the first value, which is 10. Then we add the next value, so 10 plus 25 is 35. Then we add the next value, so that's going to be 50. Now, the cumulative frequency is the total amount so far. So for that first 10, for the frequency of cumulative frequency of 10, we're looking at everything up until the 20. So we plot it at the 20. So it'd be 20 and then 10. So this one here. Then the next one, the 35, is everything up until 40. So it would be here. And then the next one is everything up until 60. There we are. Now, next we want to join them up. Now you can draw them up with a curve, and in most exams you can actually join them up with straight lines. So something you can do is just join them up with, click the right one, straight lines like that. And on most exams that's absolutely fine. I'm going to join them up with a curve. There we go. Now technically I should really finish this off with a nice straight bit there, because there's just a constant 50 forevermore. To find the interquartile range from a cumulative frequency graph, you first of all see what the graph goes up to. Here you can see it goes up to 20. And what we do is we halve that, and that's the value we use to find the median. So we halve that again, and that's the value we find for the lower quartile, which will be 5. Then you add the 5 to the 10, so the number we use for the lower quartile to the number we use for the median, and we get 15. So those are the 2 points there that we will find our quartiles. So we draw a line across to find our lower quartile, a line across and down, and I think that is roughly, I think 22 roughly. We do the same again for our upper quartile, line across and down, and that's roughly, I mean these are going up in 4s, so maybe 37, because this line here would be 36, so that would be 37. So to find the interquartile range, it is interquartile range, let's do the formula, is the upper quartile take away the lower quartile. Upper quartile is 37, lower quartile we said is 22, and so 37 take away 22 is going to be 15. Now if you've got slightly different values, that's absolutely fine. The exam will always give a bit of leeway, especially when reading off graphs. The first thing to notice is we actually have 2 radii here. So we've got this radius here and this radius here, and all radii are always equal in length. So we have an isosceles triangle here. So this angle here is going to be 19x as well, and we've got to write that down. So we're going to say angle OBA is equal to 19x, and the reason is it's an isosceles triangle. Okay, so we know these two are equal. Well, we also can work out x because, as I said before, we have a triangle here, and all angles in a triangle add up to 180. So we've got 7x plus 19x plus 19x equals 180 degrees. And this is angles in a triangle. Try and draw a better triangle, equal 180 degrees. Try and write out these reasons in full. Okay, so that's going to be, was it 45x equals 180, and let's get our solving lines in. And we're just going to divide both sides by 45. Okay, so we've got x equals 180 divided by 45, which is 4. Now, we're looking for this angle here. That's angle ABC. Now, there's a few different ways we could do this. We could work out what this angle is, because it's a big triangle, etc., etc. Or we can use the fact that we've got a tangent touching a radius. So we know that this, let's just pick a different colour, this angle here is 90 degrees. So we can write that down. So angle OBC equals 90 degrees, because it's the angle between a tangent and a radius. Again, make sure you write all the reasons in full. And so therefore, angle ABC, which is what we're asked for, is just 90 take away the 19x. Well, we know that 19x is 19 times 4, because we know that x is 4. And so that would be 76, so in total it would be 14 degrees. So angle ABC is 14 degrees. So we're going to first of all factorise the quadratic, and we'll end up with 2 brackets equals 0. And to do that, what we want to do is multiply the coefficient of the x squared and the number unknown together. So we're going to do 12 times the 6, which is 72. So we need 2 numbers that times together to make that 72. And we're also going to look at the coefficient of the x, minus 17. So we need 2 numbers that add together to make that minus 17. They need to be the same 2 numbers. So what we can do is we can write out the factors of 72 and try and find them. Or we can kind of use our head. So it's going to be minus 8 and minus 9. I knew they both need to be negative because they add together to make a positive. Sorry, they add together to make a negative, and they multiply together to make a positive. And then just trial and error, just think it through, and get minus 8 and minus 9. So we're going to rewrite the expression on the left, but instead of minus 17 we're going to write minus 9x minus 8x, or whichever way around. So we're going to do 12x squared minus 9x minus 8x. I could have done it the other way around, plus 6. We're going to factorise linearly the first two terms, and we're going to factorise linearly the second two terms. So here we can actually divide out 3x from both of them. And we always put the minus on the outside, so it would be minus 2, and that would be 4x minus 3. The repeating bracket is our second bracket, so 4x minus 3, and then the bit on the outside, 3x minus 2, becomes our first bracket, like so. So let's put that back into our equation. And to solve this now, you get both of the brackets equal to 0. So we're going to get this equal to 0 and get our solving lines in. So we're going to add 2 to both sides. Oh, right, 3 there. Add 2 to both sides. And so we've got 3x equals 2. Then we're going to divide by 3 both sides. And we get x equals, and you can write this any way you want, but I'd write this as a fraction to keep the accuracy up. So our first solution is 2/3. And we're going to do exactly the same thing to the right hand side. Get it equal to 0. Get our solving lines in. And we're going to add 3 to both sides. So we get 4x equals 3. And again, divide by 4 both sides. And we get x equals 3/4. So our second solution is 3/4. We can actually simplify the surd at the bottom. So root 12 is the same as root 4 times root 3. And the reason I've picked root 4 is because it's a square number. So root 4 is 2 root 3. So we can rewrite that as 14/2 root 3. We can divide them 1 by 2. So that'll leave a 1 there, so it'd be 1 root 3, or just root 3, and 7 there. And when we rationalise the denominator, we times the top and bottom by the square root at the bottom, which would be root 3. And so that's going to be 7 times root 3, which would be 7 root 3, and then just 3 at the bottom. So our answer is 7 root 3/3. So there are 3 parts to this power. We've got this negative here, which means to find the reciprocal of the fraction, or flip it. We've got this 2 here, which is the root that we're going to find. And then we've got this 3 here, which is just a normal power. So a lot going on. So we're going to focus just on that flipping first. And so we're just going to flip the fraction, find the reciprocal of it. So it's going to be 100/9. And that gets rid of that negative, so it's just going to be 3/2 now. Now that root, it means we're going to square root the top and bottom of the fraction. Because it's a 2, it's a square root. If it was a 3, it would be a cube root. So we're going to square root the 100 to make 10, square root the 9 to make 3. We've still got that 3 on the outside, the power of 3. And that means we're just going to find we're going to cube the top and bottom of the fraction. So cubing 10 gives us 1,000, and cubing 3 times 3 is 9, times 3 is 27. So our answer is 1,000/27. I'm going to start by getting x equal to the 0.847 recurring. And I'm just going to show that with 3 dots. And we want to bring forward everything that's not part of the recurring pattern. So what I'm going to do is I'm going to find out what 10x is. And that's going to be 8.4747. So what I've done is I've just got the recurring pattern after the decimal point. And what I want to do now is bring forward one of the occurrences of the recurring pattern, so the 4 and the 7, just one of them. So we're going to times it by 1,000. We'll find out 1,000x, and so it'd be 847.4747, etc., etc. Next, I'm going to take away everything. So 1,000x take away 10x, and that's going to be 990x. And then 847.4747, etc. Take away 8.4747, etc. It's just going to be the same as 847 take away 8, because the recurring stuff will just cancel each other out. So 847 take away 8 is 839. And now I'm just going to put my lines in. And so what I'm going to do now is just divide both sides by 990. And so on the left hand side we've got x, and on the right hand side we have 839 divided by or over 990. So as a fraction it's going to be 839 over 990. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got two radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagram as 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained, just so I can fit this answer all on the same slide. Okay, so the first thing I'm realizing is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got three of the sides, we can work out the last one. So angle DOB is going to be 360, take away the angles that we know, so 90 plus 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB, but I'm going to call this kind of the reflex one. And to work this one out, we just do 360 take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360 take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference, and the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should really put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. And let's just put the 66 degrees on our diagram as well. And the final final thing really here is that we've got a quadrilateral here, kind of arrowhead, and we've got 3 of the angles, 1, 2, 3, and we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know, so the 228, the 13, and the 66. And the reason being the same as before, so angles in quadrilateral add up to 360 degrees. And when you do that, you get the answer of 53 degrees. So this angle here is going to be 53 degrees. The first thing to notice is that 125 is 5 cubed. So instead of 1 over 125, it would be 1 over 5 cubed. And we know that when you have a negative power, it actually turns into the reciprocal of that number. So 5 to the power of minus 3 becomes 1 over 5 to the power of 3. So n is going to be this minus 3. So for this question, first thing to notice is there's a divide there, and we can actually just write this as a fraction. So 10 plus root 2 over 14 plus root 2. I'm going to keep the brackets there. We don't need them when it's in a fraction, but it will help us for the next step. So we're asked to transport this or change this into a fraction without a surd at the bottom. And so it's basically asking us to rationalise the denominator. Now, when you have 2 terms, including a surd at the bottom, we need to do something a bit special with this. And the thing we do is we times it by the opposite bracket. And what I mean by that is if it's 14 plus root 2, we times it by 14 minus root 2. And we've got to do the same to the top. And the reason for that is essentially here all we're doing is we're timesing it by 1, because 14 minus root 2 over 14 minus root 2 is just 1. So we're timesing it by 1, so we're not changing the fraction at all. Okay, let's draw a grid to work out what that will equal. And you can use any method you want. You can use double smiles and rainbows, FOIL, whatever method you have to multiply 2 such brackets. I'm going to start off with the top. The top is 10 plus root 2 times 14 minus root 2. So 14 times 10 is 140. 14 times root 2 is just 14 root 2. 10 times minus root 2 is minus 10 root 2. And then a minus and a positive make a minus, and root 2 times root 2 is just 2. Now, when you expand surdy brackets, these 2 and these 2 will add together. Okay, so we're going to start off with the numbers. 140 take away 2 is 138. And then we'll do the surd. So 14 root 2 take away 10 root 2 is plus 4 root 2. Okay, so the top is going to be 138 plus 4 root 2. And let's do the bottom. And I like these grids because you can see if you've made any mistakes quite quickly with these. You can check your working. So 14 plus root 2 times 14 minus root 2. And you'll see why in a second we do the opposite. So 14 times 14 is 196. 14 root 2 minus 14 root 2 and then minus 2. So you can see here now there's a 14 root 2 plus minus a 14 root 2. Let's just cancel each other out to 0. So we get rid of the surd. And then 196 take away 2, which is 194. So we've got 194 at the bottom. Now something we notice here is that all the terms in the fraction are even, therefore we can halve everything. So 138 halved is 69. 4 root 2 halved is 2 root 2. And 194 halved is 97. And so that would be 69 there, and that would be 2, and then that would be 97. So I'm going to first of all just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M, and M is about here. Now the first thing to notice with M, and I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is one section, we've got 4 of the sections from M to C. So just put little notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. That's why it's a nice, easy way to show that A to M is 1/5 of that distance. Let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M. We've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. Now if A to C is minus A plus B, that means A to M is going to be minus 1/5 A plus 1/5 B. Now we're asked for the vector B to M, and we know that that's going to be B to A plus A to M. We know B to A because it's labelled, it's just A. And we know A to M because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 A plus 1/5 B. And so A minus 1/5 A is going to be 4/5 A. And then we've got the 1/5 B. So it's going to be 4/5 A plus 1/5 B. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.